Very good. Thank you so much for joining us today, everyone. Today it's Wednesday, November the 2nd, 2022, and it is 2 p.m. Central Europe time. My name is Adrian Kosmaczewski. I'm in charge of developer relations at Vision, the DevOps company in Zurich, Switzerland. I'm here with Arno Aukia, co-founder of Vision, and it is our privilege to welcome you to this webinar, where we'll learn how Taurus runs its leading digital asset platform thanks to CockroachDB and APPUiO. So joining us, precisely, we have Patrick Schulz, sales engineer at Cockroach Labs, and Sébastien Pasche, VP of engineering at Taurus. For those of you attending this webinar live, there's a small Q&A box at the bottom of the Zoom window. So please use it to pose your questions to the speakers, and they'll answer some of them during or after the presentation. This event is being recorded and will be available on our YouTube channel, vision.tv. So if you're watching the recording, thanks a lot. And please remember to like, subscribe, and share the video on social media. So without further ado, I give you Patrick Schulz and Sébastien Pasche. The screen is yours.
All right. So welcome, everybody. Happy you made it here. And let me share my screen, and then we can head right into it. One second, my Zoom is kind of stuck. Apologies. Now it should work. All right. Before we're getting started, brief introduction was being made for myself. So my name is Patrick, and I'm as you mentioned, sales engineer in the DACH region, so Germany, Austria, and Switzerland, looking after our customers in this particular region. So my intent for today is, together with Taurus, is my part is going to be giving you an introduction, basically, which means we want to bring everybody on the same page, what CockroachDB is, what makes it unique, and why Taurus has chosen it as a backend for the infrastructure. And because I can imagine that a lot of people maybe have heard a little bit about CockroachDB, especially since it's a unique name at the end of the day, but are not into all the details what makes CockroachDB unique and why they should consider it for one of the future projects. So that's my intent. My intent is we are now going to dive a little bit deeper into this particular area. All right. Let's start with the fact why typically customers come to Cockroach Labs to look at CockroachDB in particular. So what are the things they're looking at? What are the requirements they have in their particular projects that cannot be satisfied by technologies they have been using in the past? And funny enough, it's a good segue also to remember Cockroach Labs, the company behind CockroachDB. So the acronym CRLS for Cockroach Labs basically can be used because it's very easy to break down the unique requirements we can have customers with. It typically starts with C, which translates to data consistency. So consistency is a key for us when it comes to storing even the most crucial data, especially in the financial space, where I think we are all the same. Everybody wants to open up their banking app and make sure the ledger is correct and the money is there and all the transactions are basically correct. So that's a key for us when it comes to customer requirements. They come to us because they want to run really critical infrastructure, real critical application that would have a pretty big impact on their customers, which is they cannot trade off consistency. That's their utmost requirement they have for the applications, but they want to run it at large scale. The next thing is reliability, so that we are being able to provide new ways of how you can basically design a database, design a system that goes beyond what they've been doing in the past, which typically is like active passive types of architectures, which means typically failover times. And what we are seeing is that customers want to develop themselves towards a zero downtime strategy. because ultimately they want to make sure the impact they are having when there are problems in the infrastructure do not trickle down and do not impact their customers ultimately. So improved survivability or reliability is a key aspect that comes with those type of customer requirements. And depending on your business model, you might have a customer base that's not just in Germany, not just in Switzerland or Central Europe. It may go beyond that and maybe a global user base. So then you run into challenges around, right, how can you handle certain performance requirements when users from, let's say, the US or the Asia Pacific area need to connect to a system that's centrally stored somewhere? How can you improve performance and especially compliance? How can you solve compliance in a context as well? Since you need to watch out what type of data can be stored where in the world. And those are areas we can help with. And last but not least is scalability. You can imagine that if you run a system or launch a new app and customers love it and they adapt your new offering, and you need to make sure that your backend can scale along with the customer demand so that the backend is not stuck where it is and gives you enough flexibility to scale the system over time as your user base is growing. So these are the key reasons why customers come to Cockroach Labs to look at CockroachDB, since those are areas we can help our customers with. All right. Next thing I would like to help you to understand, where is CockroachDB actually placed within this giant landscape of databases? So CockroachDB basically is a relational database. It's by heart a SQL database that can be used as a replacement for or any new type of project that requires a SQL type of interface, where you want to store relational data, where the consistency, as I just mentioned, is key, and where you can use the existing knowledge you have around SQL. So it will look and feel like a pretty standard SQL database. But what does it make unique? And the key being that we give you also the characteristics of the NoSQL world, which means that all of a sudden you can scale your SQL database the way you could scale a NoSQL database, which means you can horizontally scale the system, spread your data across a fleet of machines. This also will give you more resiliency because you will have multiple copies of your data distributed across the fleet of machines. And this enables you to have more flexible architectures, and especially in a multi-region context, which we'll go into more detail in a couple of minutes. But we basically blend together the best of two worlds, the relational side, the consistency and the familiarity you will have with the SQL side of things, but you will also get characteristics that you probably know and love from the NoSQL side. And all this goes perfectly on the cloud, no matter what type of cloud infrastructure it is, and even on Kubernetes types of environment as a shared nothing architecture, it perfectly runs on those types of environments as well. But the key to remember is CockroachDB, relational database. It gives you those guaranteed transactions, those asset guarantees, but with a lot of new characteristics. So first things first, when we talk about CockroachDB, we always talk about a fleet of machines, starting with 3 nodes. And from there on, you can technically scale to any number, but we always talk about a fleet of machines. The key being all those machines will be active at the same time, which is why we call it a multi-active architecture. So there is no node which stands out to be the primary or secondary or standby or whatsoever. In a CockroachDB system, all the nodes are active at the same time, all working in conjunction to power your SQL database, basically. When it comes to interacting with the system, we provide you with a familiar SQL interface. You basically can use Postgres from a wire compatibility standpoint, so you can leverage the standard Postgres driver to interact with the system. So we're Postgres compliant in that regard. And also when it comes to the SQL language, we lean ourselves towards Postgres. So when you're coming from a Postgres background, even better, then you feel very home when looking at Cockroach. CockroachDB. But even though we're talking about a system where all of a sudden your database lives distributed across multiple nodes, where all the nodes can read and write to the backend at the same time without compromising on the ACID guarantees. I think that's a key takeaway from today, is that we break with the paradigm of active-passive systems and really have built a distributed multi-active system that looks and feels pretty much the same way from an application standpoint, like a single instance Postgres would, but it gives you a lot of more flexibility under the covers without trading off the consistency side of things. And this new distributed architecture allows us, or you ultimately, at the end of the day, to scale your system very, very quickly. All you have to do is to spin up additional nodes, join them into the existing cluster, and we will basically take care of the rest. We will reshuffle the data behind the scenes for you. So there is no manual intervention needed from an operational side of view. We make sure that data is pushed to the new node so that the new node is actually, can be put to work for you. And there is no need from an operational side of view. And what's even more important than that, there is no need on the application side of things. So you do not have to have, like with traditional sharding, where you would have, let's say, multiple instances of a Postgres, for instance, and you would have to have certain type of routing logic or knowledge about where the data is actually living. That's completely abstracted and transparent for the application. So typically you could place, or would actually place, a load balancer in between the asking application and the actual CockroachDB cluster, and the load balancer would distribute and shuffle connections around and make sure all the nodes are being part of the pool so that the connections are well distributed across the fleet of machines. And your application still thinks it's a single instance system because there is no special or secret sauce to it. That's enabled by our multi-active architecture. So technically, the application could ask any node to do an insert, an update, or to drop some data, and eventually the data or the request will succeed, basically. So the application doesn't have to have any special logic or knowledge about it. That's something we really take care of in the backend of the application, of the database, actually. And this also enables you to build new architectures. So you can all of a sudden stretch your system across multiple regions, which is pretty unique because you now can have a couple of nodes sitting technically in different parts of the world, different parts of the country or Europe, wherever your user base or application is running, where you need to have access to the database. This brings data, or can bring data, closer to its users and cut down latencies for them. But this enables one key element when it comes to resiliency, is that it gives you all of a sudden regional survivability for your database while maintaining an RTO, or basically an RPO of 0, because we will create the necessary copies of your data, distribute them across those regions. So I will end up basically with copies in region 1, region 2, region 3, which enables you that region 3 can go down at any time. You still have copies in the remaining regions. And this allows now that your application doesn't have to fall apart just if a cloud region goes down. You can ensure or work your way towards a zero downtime strategy, even in the event of regional outage, because CockroachDB has made sure that there are consistent copies distributed across multiple regions. So what we basically help you to do is really work your way towards a zero downtime strategy. And in this context, I briefly touched on it. We're talking about an RPO of 0. So there will no data loss. There is no lack of data like in previous architectures where you would fail over from an active to a passive instance, where you would then have to incorporate the lag that would be on the secondary side. That's all gone. And we are talking about an RTO of just a few seconds. So just to shift some responsibilities around, and eventually the application will get a result. So RTO close to zero, RPO of zero really helps you to drive that home. And also on the operational side of things, we help you with things like rolling upgrades, that you can do in-place upgrades of your system. So there's no complex process around it. You can really do in-place upgrades, one node after another. There is no complexities to like take offline in the system or export data, import it into a newer version. We really want to make that really, really simple, and also allow it to do online schema changes, which means that you do not have to think through all nitty-gritty details. If you found at some point, right, you need to change your schema, you add something to it, feel free to do so. We will send it in the backend, rework under the covers what needs to be done. And once we are ready, we flip the schema, and then you can flip the switch on the application side, and then you can start the new schema. And while that is in flight, just use the old schema. So there's no need to take the system offline or build a complex process around schema changes. We will help you to do that. That's why we say survive anything. It's not just having the resiliency and copy data around, it's also the operational side of things we would like to help you with. And then there's one aspect that means if you run in a distributed fashion, means you have to decide if you want to have copies everywhere in all the regions in order to survive a regional outage, or if you want to go down the path and say, no, some data might make more sense to stay in Germany, stay in the US, for instance. Think about GDPR, for instance, when it comes to where certain data is allowed to be stored. Then we can say for certain rows, the data is only replicated across a certain number of machines in a particular home region. So that you have a giant table, and let's say all the user entries for US citizens are stored on US nodes, and all the entries for the European users are stored on European servers. So we help you with compliance even down to a row level where data is living, and data would be still replicated across a couple of nodes within this particular region. And this also gives you the advantage that data lives closer to its users. So the user doesn't have to go all the way through half the continent to get to a centralized, let's say, Postgres instance. They really can go to the closest instance within their respective home region. So you can save latency basically because you have to travel less from a user perspective to get to your data. And two last slides from my end to get everybody on the same page. Technically, just everybody has heard about it. There's multiple ways how you can consume CockroachDB. There's one way, which would be CockroachDB serverless, new offering from our end that gives you pretty flexible, let's say, developer type of environments where you can start very small, can even scale down to zero if it's not needed. So especially in early days of a development life cycle, and really consumption-based billing for that. Then there's the flagship cloud offering, which would be CockroachDB dedicated, which means you get a dedicated installation in one of your cloud of choice, like AWS or GCP, for instance, all managed by us, or CockroachDB self-hosted. And as the name indicates, then it's up to you or partners of us to really run it for you, which then means the deployment process, the upgrade process, the monitoring, etc., would be up to the party that's going to run it. And just to touch a little bit upon what it means when it comes to self-hosted and the differentiation, let's say what's possible in an open source system versus the enterprise system. So obviously you can imagine if you put a system like CockroachDB into a production, especially in an enterprise production type of environment, you have to think about a couple of bits and pieces, like the security side of things, to make sure data is encrypted or SSO, so single sign-on. Who can log in, what type of identity provider to the system, for instance? Or can you make sure that your backups are encrypted, or that you can do really incremental backups in really granular point in time restores for your data when things would go wrong, or that you can stream your changes from your OLTP type of database, which CockroachDB is, let's say, optimized for, and you want to have your changes downstream in OLAP type of database for analytics processing, we can use CDC, so change data capture, to stream those changes out to analytical systems, for instance, or that will help you to simplify the multi-region configuration, that it's really just a couple of SQL statements you would have to issue in order to turn a couple of nodes into a fully fledged multi-regional system that give you the multi-regional survivability. And last but not least, of course, support, that we can really help you with strict SLAs on the break fix front in terms of success teams that really help you to how you get from maybe a proof of concept into a production ready environment with our customer success manager, with our enterprise architects that really help you to be on that journey with you to bring you from, oh, we just heard about CockroachDB, we do POC, and now we want to productionize it. That's where we are there to help, along obviously with typical enterprise break fix support as well. All right, that's it from my end. I hope the introduction brought everybody on the same page and made it a little bit clearer as to why Taurus has chosen it as a backend. And with this, I'll hand it over and stop sharing my screen.
Yeah, thank you. And should be sharing now. I just need to position the chat box so that way I can see if somebody have a question, because that was something that was asked. So cool, welcome and thank you everybody to be there. So I am Sébastien Pasche, I'm the VP Engineering of Taurus. I've been in Taurus since the first day, and I will explain to you mostly what we do with CockroachDB. I know most of the attendees today are in the technical side, so my slides are a bit minimalist on that, on the content, focusing more on the questions, but I keep some numbers on things that we, yes, I can do full screen presentation. Is it better now? Yeah, I think so. So yeah, so the I will go through the different use cases that we have and some numbers on from the field story that we get from Cockroach, because it's a great product, but it also have not its limitation, but its use case where it performs well, on use case when you need to do trade-off, like any product. There is no silver bullet anyway. So from the perspective of Taurus, I will start by explaining to you what we do. We do mainly two main activities, one with the three products on the left, one with the single product on the right. And from the left part, that's our core business currently. It's enabling a financial entity to do business with crypto assets in a large, broad perspective, coming from blockchain currencies at Bitcoin, digitalized currency, digitalized company shares, like you would do on Actionaria, some NFT, like you saw the different monkey or other kind of NFT, also payment networks, and also other digital assets that are not even blockchain, but just a digital representation of an existing asset. And this is the first part of the business we do. On the right side, what we do is, because you will issue some digital assets, you will need to trade them, and we have a marketplace which is FINMA regulated. And if anybody in the attendees is from a banking world, you know what that means in terms of compliance, in terms of audit, periodic audit, and so on. So we have the two perspectives. We offer software to our customers, and we also use it ourselves, and we have the same requirement as our customers. So we develop the software in a way that it fits our needs and our customers' needs. In terms of products, to keep in mind, we have two big families. We have Protect and Capital. Taurus Protect is a crypto custodian. In a basic way, it allows you to interact with the blockchain ecosystem or with the crypto asset that you use, like moving Bitcoin and safeguarding them and protecting those assets and the private key link to these assets via some compliance layer that you could have, like adding multiple validation, adding forage, double replay protection, detecting fraud or detecting dirty asset, and so on and so on. That's the core business of Taurus Protect. Capital is a solution for tokenization and asset management. So that means it allows you to use a smart contract, create a new asset, and follow up on the life cycle of the asset, creating new token, creating new company shares, burning them, editing some rule for the transfer that you would apply if you would like to have some logic into the contract. And those modifications will go through Protect, and this allows you to interact with the blockchain and also to connect it to your ecosystems. Most of the product, or a good part of it, is this connectivity to classic banking environment. Could be OMS, which is used to find the best order amongst multiple counterparties. For example, if a customer wants to buy a Bitcoin, could be core banking, where your real account are, could be a representation of the IMS system for the money laundering, where you query several systems to get a scores. So we really are an enabler for those entities to get access to the crypto asset environment and connect it to the legacy world or the existing world. On the middle, you get Taurus Explorer. That's going to be really an interesting point to discuss in terms of Cockroach integrations. It's basically a huge index of the blockchains that follow the blockchain in real time. It indexes everything into database, and it has several particularities that blockchain grow all the time, and also they grow faster all the time. So that means it have to absorb more and more data, and cleaning them will not be possible. So you are in the case of an ever-growing database that is queried a lot. Because when I mean a lot, is I will see the number, it's a lot. So in a summary, custodian entity for the bank on financial institutions, allowing them to enable crypto market access, an explorer for the connectivity with the blockchain on everything you can imagine when you have an index of all those data stored somewhere, and finally, a marketplaces where you can buy and purchase those crypto assets. In terms of story of the company, I think to know is that we are younger. We still are young. We come from 2018. We have several lead public customers in Switzerland. We are currently one of the market leaders in Switzerland and expanding into Europe and even worldwide now. And we started day one with CockroachDB as a database for managed services. That means when Taurus decided to deal with manage the service for the customers, and of course we support other database for on-premise use cases if customers don't want to use Cockroach. But we started with an open source version. That's an important point. Then we grow to the point where vision come into the play, because we are a company developing crypto asset solutions. We are not a DevOps company. So when we saw that we were spending more time managing our environment instead of developing new features, which has value-added business, we decided to make the move on search key partners to just outsource this environment. And now Vision are hosting 100% of our managed services infrastructures, the Explorer, and also all the crypto asset exchanges platforms. Everything is hosted and maintained by Vision. And that was one of the key points in terms of IT for us. Then we continue growing. We get more and more customers. We get database which are more and more bigger, especially the Explorer one. And at some point, we really at a threshold where we had a large amount of data, several terabytes of data into the database, and we discovered that system getting slower. We didn't been able to find why, even if we reverse engineer some of the range analysis and some of the distribution system and so on all the layers. We decided, okay, no, it's getting us more and more times to optimize our query, to optimize the way we work with Cockroach. We need help. And at that point, we moved from Cockroach open source to Cockroach Enterprise. That was the beginning of last year. And since then, Cockroach team is helping us to improve our systems. A good example is we have been able now to double the number of customers, but the clusters still are the same size. So kind of a good experience from our side and from the financial perspective. So what the investment, in the meantime, we get our FINMA license and we started to onboard like some of the biggest banks you can imagine. And we have high level of requirement, as you can imagine, as a critical outsourcing, we have to respond to a high requirement. So for summarize, we have products that can be hosted on premise, that can be hosted as a managed services. where we need to ensure the quality of service. And we also need to offer an hybrid solution where customers can decide to distribute systems amongst the various, like having part of the custodian on-premise and part of the custodian on our managed services. So they are free to distribute the system however they want, and it must work. And all hybrid and SaaS setups leverage CockroachDB on a large scale. So that was for the main use cases we have on what we offer. As you can imagine, database growing and so on. And now we'll discuss about our use cases in a more Cockroach way with more detail for people who used to play with Cockroach. So first of all, we have some objective with Cockroach that we need to achieve because we are a FINMA audited company on our managed services have an ISAI type 2 with some strict control. Our storage must have encryption at rest, even if people could argue is it useful or not, that's still a box you must tick, otherwise there is no other chance you can run a business in this area. And also you must have your backup encrypted. There is a way to do it yourself, much easier when it's out of the box and it works with a single command line. Data integrity, as you can imagine, because you get the balance of your customers within our systems, it's absolutely critical. You cannot allow any data loss at any point in time. This is just unacceptable for the custodian. Explorer is a bit different because those data are still on the blockchain. There is more flexibility on this, and we will discuss about it later. In terms of availability, same, as we don't want to be a DevOps company. That's mean even if we have our past systems highly available or not managed for us, we still have these databases, and failover should be smooth, should be automatic, and should not require somebody to wake up at 1 a.m. in the morning to do a failover. This will not be okay, and also it has to have a low maintenance cost, for which Cockroach is really well done in terms of being ops friendly. It's very easy to maintain, it's very easy to upgrade. So there is almost no cost in those low management layers. Things get a bit different in the software, but anyway, you are a software company, so we have to do it. In terms of use case and workload, as said, we have 3 main platforms. So the first one is the heavy hitter, is the blockchain indexes. Blockchain, basically, you're always appending data to table. We have some of our table, which are now close to, when I looked this morning, 9 terabytes. That's a big table. This table will be right on the top at all the time and query over all the data all the time. And one of the very picky things with this is that any outage of these systems is hyper visible because systems start working instantly. There is no tolerance for this. And it has, of course, it's a high value impact on the customer side because basically trading stopped. So you really need to be highly available. We decided to go with a schema of having 2 systems geolocalized because we hit one of the first limitation we face. Migration, like the automatic way, work very well for a ton of use cases, but when you add 3 new columns with an index on a 7 terabyte database, a table, and you have 20 of those tables, and you do this at the same time on the clusters, I can promise you it's not gonna work. Just because physically it's going to be too intensive for having it transparently done. It's gonna impact your performance, latency gonna spike up. So we decided for this case, we're not going to do that way. We're going to replicate data by hand and migrate one server, one cluster after the others. This is one of the caveats we found. But a good point, I would say, we reached that limit where our database gets several terabytes large. So before that, everything was magic all the time. On the managed services platforms, where your load is more like a CRM system at the end, or classic trading systems, things are just magic, basically. It's okay. Data integrity is very crucial. You cannot lose any data, but you can stack up really a lot of environment on the same clusters, creating database, of course, and scaling go very well. On there, we have the full advantages of Cockroach. And for the exchange, it's the same kind of load, even smaller because we have way more in the managed services, but we see those 2 things. There is like the classic database usage most of the people have. I used to be in the e-commerce before for a website you maybe know, which is called Le Shop, that I had to design. And the issue we had were mostly the same. If you translate the ecosystem that we have in managed services, and we solve them the same way. Only this huge index of blockchain caused some issue. And what we did also, as said before, we also defined key point of failure, because that's something you need to do anyway. So we wanted to be able to lose a single machine. So that means a node or an hypervisor directly. We would like to be able to support a cluster failure that should move back to the fallback region. That's typically for the exchanges, because for the blockchain, because for the other system, it's transparent. And we would like also to be able to lose both a primary region or a fallback region, and this should be as automatic as possible. And for now, we are almost entirely automatic. And when we did the last test in production, we had 0 performance impacts on this. And one, which is a very important point, because cap theorem being the cap theorem, if you lose 2 regions, you also need to lose absolutely no data. So in terms of priority, it's better to not lose data than being available. That's true mostly because those are financial transactions. So those were our key points when we make the design of the system. And that the first tips I would tell you, you need to do this exercise before designing your cluster, because after this, when you get a lot of data on it, it's going to be more complex. In terms of clusters now, we have basically a dev clusters that an average load with good performances. We have an acceptance clusters because we move from the test to the acceptance. And then we have the 2 production clusters. So this first one is even bigger now, but that's the cluster for the blockchain indexes. When you could see, we have a very high P99 latency. And this is normal, because whatever you do, when you need to scan a 2 terabyte table, it's going to take time. And throwing resources on the problem do not solve it. But a very important point I would like to emphasize, those performances are linear in the sense where if you add load to the clusters and you add nodes corresponding, the performance remains the same. So you have an expectation of how performant the system will be, and you can adapt your software with cache on other kind of data. And this is very convenient, especially when you would like to forecast the price of infrastructures. And finally, it is the managed services environment where things operate very well with good performances. And we even see that the increase of performance in terms of number of environment for customers you can run is not like linear. If you have 20 customers, let's say on 2 nodes, when you add a new node, you can go almost to 40 environments because of the overcommitment of resources that are victim, because nobody uses the resources all the time, and scaling go very well for those classic use cases which are not super intensive on writing in the same table, that means in the same array, which are like the worst use case you can imagine for a distributed system. So those are our observations that we see since 5 years now, and those are repeated from the small size when we started our clusters, which has only 4 CPU, to know where they are really bigger, is same observation since 5 years. For small details, for people who are interested in how technically we deploy, we currently have 3 regions, and we interconnected via tunnel. So of course, we don't expose our systems online. And this is more to emphasize that Cockroach is highly latency resilient, which is a good point. That's mean even if you connect your data centers, which are located in different regions, and there is latency between them, and you like to protect the traffic with a VPN, a Cockroach tunnel, any other solutions of doing HTTPS tunneling, is going to work. You're going to be perfectly resilient, and they're going to work fine with higher latency than the classic super low latency distributed system require. So that's also a good point, that you have a lot of margin. I would say by what I experimented, up to 70 to 100 milliseconds systems work well for systems at normal payload, and for the super high intensive one, try to be more around 40 and 50. That's one of the takeaway. These are small tips also about how we deploy. Clusters are connected. We're using Cloudflare tunneling. That things it's something is doable that allow us to geolocate our clusters without having to rely on provider to provider linked between data centers. This is important when you want to move things around easily. And also we leverage the real-time encrypted backup with your local history. And one of the tips that works for us is to re-encrypt the backup to store them somewhere else. That allows us to segregate the admin DB, right, which is allowed to put the backup into the S3, basically unload them, and the team in management of the backup. So that way we can have a strong segregation of duty. Admin DB cannot go to a backup, it has to be restored by somebody. And this is also a convenient way. I knew from speaking to people around me, there was an issue that people ask me all the time. So I said, at least I can give it to you there. And to sum up this presentation, in terms of why we choose Cockroach and why we are happy with, we are a fast-paced company and we are a young one. We need to enter market quickly. So we need to have new customers, new currency, new service, new location. And what figure out what are really good things, because at the end, all of those requirements mean you need dev, having a standard SQL languages. So you have all the distributed things that are high hidden. It's a very easy way to enter into the systems and an easy way to onboard your new coming developers. So that means you can work with more junior people and seniors instead of relying on heavy senior people experimenting into distributed database creation or maintenances. Scalability, being horizontally scalable is very good. The semi-linear scalability, because of the kind of use case we have, is also good because you can easily forecast the number of nodes you need. You can forecast your budget for a growing way. Those are very convenient, and they are really, really easy to deploy and to integrate into clusters. In terms of compliance, of course, we leverage almost all the features that Cockroach offer. We have the encryption at rest. We're using the SSO at SQL and at the interface level. We're using the audit log, and of course, as I said before, we're using the backup. And finally, I would like to emphasize and take some time with the support, because since we hit those issues we had with our big Explorer databases, we really relied on them, and they were always quick with very technical responses. They spent time with us analyzing our query, analyzing our deployment, understanding our problems, and finding solutions that fit our requirement instead of forcing us into a known pattern. So they took time, week after week, to do long optimization and modification of our schema, of the way we do our query, of the way we do our jobs that pull or fetch the data to be more scalable. And this allows us to double our customer bases without doubling our clusters, which is performance that I would like to emphasize, and thanks them for this. And also they have been really dedicated on that. So you have your own enterprise architect that know your project, that follow, that is accessible, and you could discuss with him when you have new project and so on. We as Taurus really appreciate this. And that's most for the overall presentation. I make it a bit shorter because knowing those Cockroach is often not problematic, but the question comes from the technical or field question. I wanted to leave some time for questions. So floor is yours if you have any questions.
Thanks a lot, Sebastian and Patrick. Yes, there are no questions so far, but maybe somebody is writing one right now. So let's wait for a few seconds on the Q&A box.
That's the stress now.
Excuse me?
This is the stress now. Like, please, some question. No.
While we wait for some questions coming in, one, I think, really cool part, which kind of went untouched a bit in the second part, is that you really run CockroachDB distributed across 3 OpenShift clusters, ultimately. That gives you that extra resiliency so that you really run it across independent infrastructure, and even could leverage on the Kubernetes side of things when Cockroach is running as a pod. Ultimately, things that if a pod fails, Kubernetes will notice and automatically reschedule the pod, and the cluster can self-heal as well. So there's a lot of things, or actually nuances, you could, in general, for the audience, uncover or get added value, especially if you build an architecture on an orchestrator like Kubernetes, where you all of a sudden have a distributed system across independent OpenShift clusters. So there's a lot of details we could talk about today, but the time will not be sufficient to do so. But if you have maybe questions around that as well, feel free to
Yeah, that's a good point. What I could say, I could just summarize our technical stack. We, as you saw in the slide, leverage Exascale, where we have dedicated hypervisors. On top of it, we have manage OpenShift from Vision. And then we worked inside of different namespaces that we create, which are in our own environment. And as Patrick said, we leverage those benefits from Kubernetes, where nodes are managed by the clusters. And then you can, of course, have the respawn. You can move data around if you want. And then going to be question about, would you like to use distributed storage and keeping just the pods into the clusters, or using local storage, which are assigned to nodes? Those are more defined by your use cases. Typically, the blockchain explorer not going to work to have a central integration systems, because we need super low IOPS, super high IOPS. I mean, we are close to 300,000, so that's a massive one. And if you do classical payload, then you can use or leverage those capacity to have a block storage. And that means your cluster is almost unbreakable, because at the instant a node go down, it's going to go up somewhere else. And you're using also affinity rules, so that way you avoid pods to run on the same nodes. So, and you prioritize those resources that will also leverage you availability services, but that's a bit more detail. Oh, I have a question from Stefan.
We have a question from Stefan. I'm going to read it just for the recording, for the people who watch the video. Stefan is saying, I'm curious how identical CockroachDB is at the wire level to Postgres. I remember trying it out with Django once, many years ago, and there were some problems with some edge cases. Unfortunately, I don't remember what exactly they were, probably regarding schema migrations or more special field types. Sorry, probably a hard to answer question. Don't be sorry. Stefan, thank you so much for your question, by the way. So, Sebastian, Patrick, what do you have to say?
Go first, Patrick, then I will speak from with my experience on this.
I mean, I'm not a Django expert, so I couldn't tell you for 100% like how is it today on that front. But generally speaking, at least you attempt to be as generic as possible in terms of being able to leverage the default Postgres driver. I know there's one or two frameworks where we have, let's say, made some enhancements or additions to the existing one, so that it's unique to this particular framework then, so that we can address some of the issues that may work with the out-of-the-box driver. But I'm not sure how it's on your end with, let's say, what languages, what frameworks you're exactly using on your tech stack. So maybe you have some insights on that as well.
Yeah, I can explain to you a bit my story with Cockroach. I started using Cockroach probably 8 years or 9 years ago when I was at Le Shop. Then I worked for an IDP provider, which was a sub-company of the group Elka. Then I am now in Taurus, so that I saw the evolution. So at the beginning, yes, most of the ORM, basically like Hibernate, were not working at all. That's due to the PLSQL that was used, some very specific Postgres annotation that was used that were not working. But outside of this, the SQL level is completely good. And if you use light ORM, usually you have no issue. That's more when you use completely object-oriented ORM at the time. That was the issue. Then when I worked with Elka, I had a cool use cases. I had to migrate the Keycloak IDP to Cockroach. And this was a fun experiment. It also made up several non-pull requests for this, because Cockroach is transactional systems. And if you would like to have some of the temporary feeds being valid, you need to query always the same nodes because the write has to be done. And that was an issue with Hibernate. So at the time, we had to make the several write and read a single transaction. So we had to write into a singleton that was deployed into a GBus things. But that was one of the issues we had. But at the end, when I left Elka, most of those limitations were lifted by Cockroach because the improvements were done. Now that we work at Taurus, we work with a very light ORM that's mostly help us for validation and data mapping, but it's not an heavy ORM, and we faced no issue at all in terms of the SQL integrations. And we also start to leverage Cockroach specific type of query especially for the Explorer, where the data set is so massive that we need to. But we so far I never experimented something really limiting in those 5 years in Taurus, and we use it massively.
Excellent. Thanks a lot, Sebastian and Patrick. We have another question. I'm going to read it from Stefano Nico. Can you please tell me, how does CockroachDB integrate with modular designs? Is it also measurable on I/O level for limited resource environments?
So I'm not 100% sure if I got the question. If you got the question, feel free to give it a shot. Otherwise, Stefano, you may want to provide me a little bit more context so that I can wrap my head around it.
I can give Stefano the possibility to ask his question directly live on audio. So I'm going to do that. Give me just a few seconds, and I'm going to, Stefano, I'm going to allow you to talk. There we go. Stefano, go on if you would like to ask your question.
Hello, nice to meet you. Do you hear me?
Hi, yes, we can hear.
Hello, so when I mentioned about modular designs, is the ability to shift CockroachDB as a database backend to multiple applications and interfaces, you know, how polyvalent is it working with Java, JavaScript, PHP, and so on? And the other question, I mean, the database system of Cockroach usually has, like any software server, it has a buffer memory management, times when it flushes to this data or does in-memory processing of queries, and what is the possibility to measure there its resource consumption?
I mean, when it comes to, I take the second one first, so that we basically expose all the metrics so that you can basically fetch the metrics from an API endpoint so that you could track like CPU consumption, memory consumption, and all the metrics we eventually expose from the system and put it into your, let's say, Prometheus, and visualize it using Grafana, for instance, so that you could have a full picture about what's going on in those types of environments. And obviously you could use CockroachDB as a, let's say, generic type of database for all sorts of use cases, so that you maybe run it in a centralized place and then have multiple teams shared as a cluster, and each team gets to use its own database for their various projects and languages they want to use. So it's absolutely generic in that sense, if I got it right.
Nice, thank you. Thank you very much.
Welcome.
And in terms of languages, it works with absolutely all the PostgreSQL driver. So that's usually supported by, I think, most of the language on the planet.
Okay, thank you very much.
Thanks a lot, Stefano, for your question. And I don't know if somebody else would like to answer. We still have a few minutes to ask a question. Let's wait for a few seconds for people to type. Exactly, we have one, so it was good to wait. We've got Stefan once again asking, you mentioned that region awareness could be exposed at SQL level. Does that mean that there could be basically a column on a table that represents the region, and we could control in which region CockroachDB stores the row in from our app like that, for example, for compliance reasons?
It's pretty much exactly that. So if you create a so-called regional by row table in CockroachDB, you still have your regular table with a lot of entries, all the individual rows. But what you will basically get is an additional column, by default hidden, which includes basically the locality information. So that, let's say, the first row has the locality information EU, for instance, then this particular row will only store it across nodes that also have the locality information EU. So this then happens automatically. So if you start CockroachDB, every node gets its locality information so that the system can differentiate, right? These nodes, let's say, are running in the US, these are in Europe, and these are in the APAC area. And then this column basically is the deciding factor if a row is kept within a single region and then only replicated across those nodes within this particular region. And you can do it two ways: implicitly, which means you do not have to fill the locality information yourself as part of the insert. Just do an insert against the node in the region, and we will automatically populate the information for you based on the node who has received the insert. Or you can explicitly do it as part of your insert, fill the field with the right locality information, and then the result will be the same, just if it's like implicit or explicitly done, but the result will be that the data is kept in this particular region. Exactly.
Excellent. Thanks a lot, Patrick. I hope that answers your question, Stefan. I don't know if somebody else would like to ask maybe one more question. We still have 5 minutes before the scheduled end of this webinar, but it's been really, really interesting to hear all of these opinions and all of these experiences as well using this technology. Very, very exciting. Let's see if somebody else would like to ask a final question. Well, maybe not. Then in that case,
that's fine.
Exactly. I mean, I think it was really, really cool to have very interesting questions. Thanks a lot, Stefan and Stefano Nico, for your questions. And thanks, Sebastian. Thanks a lot, Patrick. And thanks all of you who attended live this webinar. I hope this information was useful to all of you. And again, please stay tuned. We organize these webinars every so often. We'll be delighted to have you back, and see you soon in another webinar. And thanks again, Sebastian and Patrick, for your presentations.
Thank you. Bye.
Okay, bye-bye.
Bye, everyone.